make R1 the subject of the following equation. All right, so the idea here is we want to take R1 here, and we want something in the form of R1 equals something. And so what we're going to do is we're first going to get R1 on its own side. So we're going to do that by doing 1 over R equivalent. This looks like a adding resistors in parallel type situation. R3 equals 1 over R1. Now we want to take the reciprocal, basically flip this over. The challenge is flipping this part over here. So the easiest way to do that is to start with a common denominator. And there's probably quick ways of going through this, but I'm going to start by just combining two of them, then I'm going to combine the other two that are left. You'll see where this is going. So the idea here is you want a common denominator between R equivalent and R2. And there's two things you can pretty much always do in math, vaguely speaking. You can always multiply by 1, you can always add 0. So what we're going to do here is we're going to multiply this by effectively 1. So we're going to do R2, that's a 2, over R2, which is 1. Any number divided by itself is going to be 1, times 1 over R equivalent, minus, and then I'm going to do R equivalent over R equivalent, which is again 1, multiply this by the 1 over R2, and then I'll just leave the 1 over R3 over here. And that still equals 1 over R1. So then, when we look at these together, R2 times 1, because we're just multiplying by 1 here, multiply the numerator, the top, and then the denominator, the bottom. So we have R2 over R2, R equivalent, move down just a little bit, minus R equivalent all over R2, R equivalent. And I just swapped these two around. We can do that. And so then we still have minus 1 over R3. So now since these have a common denominator, the bottom is the same, we can then combine them. Hop, hop. So then we have R2 minus R equivalent all over R2 times R equivalent minus 1 over R3. So now we're going to try and combine these two. And the way we're going to do this is we're going to multiply this side on the left by R3 over R3. That way the denominator is going to pick up an R3. And this over here, you can see it's missing an R2 and R equivalent. So we're going to multiply the top and the bottom, R2, R equivalent. And again, we multiply the top and the bottom because that makes it the same as multiplying by 1. And this is 1 over R1. So then, looking at this, we have R2 times R3 minus R equivalent times R3 minus R2 times R equivalent all over R2, R3, and R equivalent. I know my handwriting is terrible, but such is life. And this will equal 1 over R1. That's supposed to be a 1 up there. So what we did here was we just did a common denominator. I only did 2 of them at a time, though what we really could have done is looked at this R equivalent and be like, all right, we want to combine all 3 of these, and so we'd have to have it R2, R3, R2, R3 multiplied by this one. Could have then looked to see which part was missing there and done the same with that one and just kind of worked our way across. It would have been a little bit quicker, but I like to just combine 2 of them at a time. Keeps you from getting lost. Okay, so we're left at this point right here, and we want to find R1 on its own, and so we can just do the inverse of this, basically flip them and flip it over here. The reason we couldn't do that before is because when you have this negative sign, just flipping them gets more complicated. So you want to have everything together as a group, the top fraction and the bottom fraction, and not trying to add fractions to find the reciprocal. All right. So then, final answer, R1, I can do a better R1. R1 equals R2, R3 times R equivalent all over R2 times R3 minus R equivalent times R3 minus R equivalent times R2. And this would be your final answer. So hope that helped. Key idea here was isolating R1 onto its own side, combining the 1 over resistances using a common denominator, and once they're all combined, then you can flip the fraction. Take the inverse, so to speak. So hope that helped. See you next time.